So it's week one. This is our first screencast. So for this week, we're only going to have one part. Usually for most weeks, we'll have a part one and a part two. So we're going to get started. We're going to build a few pages, simple pages with Node.js, and then we're going to get into working with Git. So everybody should have Node installed. We're going to be working a lot with the command line, which is something probably a lot of you haven't done a lot of and you're not that comfortable with. Well, you're going to get really comfortable with the command line. One of the other nice benefits of working with Node. So if you just click on start and run, if you're on Windows, are there any Mac users in the class? If you're on a Mac, you want to open up your terminal. So I'll run CMD in Windows and it'll take me, and it should take you, your default directory should be, if you're on Windows, C users and the user account you sign into your machine with. If you're on Mac, it'll again, I think, have a USR directory, and your username should be the location where it takes you. In order to check, we want to just make sure Node is in fact installed and running. So to do that, if we just run the command node -v, this should give you the version number of Node that's installed on your machine. So I'm running 6.4. Is that what you're running? You're running something newer? 7. So I probably should upgrade mine. I'll leave it at 6.4 for today. 6.9, that's fine. Okay. Now, what I suggest we are going to do, because we're going to be working in the command prompt all the time, what I would suggest is that you create a folder right here and put all your work in here. Otherwise, we always have to browse to a different directory every time we open our command prompt. This is our default, so we may as well do our files right here. So what I'm going to do is make a directory, and I'll call it COMP2068. I'll call mine Winter 2017. You don't necessarily need the Winter 2017. I'm going to be teaching the course again, and I probably already have a COMP2068 folder.
Should we label it the same as what our Git repository will be so that it
doesn't matter? You don't have to. It's up to you. You can put it anywhere you want. The only thing is if you put it somewhere else, every time we open the command prompt, you'll have to browse to that other directory, which is fine, but you'll have to do a whole bunch of cd change directory commands. You could do that as well. So you can put the folder wherever you like. I find it's just easier to put it inside of my user directory.
In VS Code, actually, they have a terminal inside it. So you can have the code and terminal.
Yep, you could do it that way as well. You could do it that way as well. In fact, whoops, sorry, I'm going to do it this way. I'm going to make a directory. Yeah, actually, I'll call it that. I'll keep it there. But you don't have to put it here. You can put the directory wherever you want. Okay, so I'm going to make a new directory. And then I'm going to go inside of this directory. I'll do CD for change directory. But yes, you could use the terminal within your code editor. You can certainly use, Joel, any path you like. You don't have to follow this. So I've created a directory, and I'm going to go inside. If I do a dir or on Mac, the command is ls.
I'm using a virtualization.
Okay. So there's nothing in here. So what I'm going to do is I'm going to make a new folder for each week, and then I'll tie the repositories to those folders. So I'll just, but I'm not going to use the exact same name. So I'll make a new directory in here. I'll just call it lesson 1. So all the files we do today will go in here, and that way I'll make a new folder for each week. Okay. And then I'll, again, change directories. So now I'm inside of my lesson 1 folder. And my lesson 1 folder, I do a directory command, it's blank, right? Just an empty folder. So we're going to create a few JavaScript files in here, and then we're going to use the terminal to run them. So now I'm going to open up my code editor. I'm using WebStorm. You can use any code. I mean, you can even use Notepad if you like. I don't recommend it because it doesn't support Node.js, give you code hinting, etc., syntax checking. Something like WebStorm, Visual Studio Code is going to do those things for you. If you want to use another editor, you're perfectly welcome to. So I'm just going to open up that new folder I created. So inside of my R Freeman, here's my COMP2068 lesson 1. So I'm just going to click on that and open up this folder path. It's going to be empty. So we're going to create the world's simplest Node file, and then we'll run it. So I'm just going to right click on my folder, create a new JavaScript file, which I'll call hello world. I don't need to give it a .js extension. WebStorm will automatically give it a .js because I picked JavaScript as the file type. So WebStorm actually gives me this 3-line comment. It date stamps it, puts my username as the author. I can get rid of that if I want. I'll just leave it in. So all we want to do is launch this file from our command prompt and have it print out a hello world message in the command prompt. So to do that, we use the console.log function. That's how we print messages to the command prompt. With JavaScript, you can use single quotes or double quotes. Single quotes are the convention. Next week now, the web students get a similar course to this. I'm actually teaching it at 3 o'clock, basically the same lesson. The only difference between them and you is they've already taken a full course in client-side JavaScript, which you guys haven't. So next week's class, we're just going to do kind of like a basic JavaScript class, okay, because you guys haven't gotten that. So we'll save this file. So all I need to do to run this is go back to my command prompt and now use the command node and hello world. I could put the extension on, but I don't have to. It knows it's a JavaScript file. So if I execute the hello world JavaScript with my node command, it just prints out that message to the console. Not too complicated, right? Hello world should never be complicated. So there's our 1-line file. That's it. That one's done. First node file is finished. Questions so far? Fairly simple. All right. In the video we watched, he launched the basic one that ran at the command prompt. He also showed us how we can load a node file in the browser. So let's make a separate one. And this time, not only is the file going to print a message at the command prompt, we actually want to be able to load it in our browser and have it display content in the browser. So let's go ahead and make another JavaScript file. We'll call this one server. You can give it a different name. It doesn't really matter what you call it. So this will be our first node page to load in a browser. Comments in JavaScript are the same as comments in Java. So / for single line comment, / and /* for multi-line comments. But a lot of the syntax is going to be nothing new to you guys. Have you done one Java course or 2? I think you've done 2, right? Okay. So in this one, we need to launch this page in a browser. We need to use HTTP. Now, in the past, when we did it in your PHP class, right, you guys, I think, probably used Azure or used DreamHost as your HTTP server. With Node, Node comes with its own HTTP library. We can actually run our own server right within Node.js. So when you run that install, Node installs a whole bunch of libraries we can use. And one of those libraries is called HTTP. So we want to use that library in this page. So we're going to reference the HTTP library that ships with Node. And doing this is pretty similar to how we do it linking in an external file in PHP, and you saw him do it in the video. So we'll create a variable. I'll call it HTTP. And we'll use the require function. We have that function in PHP. You probably used it with Sean, or maybe use the include function. which does similar thing, references an external file. Notice about this is different than PHP though, and different than Java. What is this telling us? It is a variable. If this was Java, we wouldn't be using var. What would you be using instead? Yeah, we'd be using some data type. Okay, so that's an important distinction between Java and JavaScript, right? What does this tell you about the typing rules in JavaScript? Scott? It's loosely typed. So variables do not have to have a data type in JavaScript, unlike in Java. Okay? And in PHP, we don't even use the keyword var. We just have a $ in front of it instead. So we're going to start an HTTP server asynchronously. So we're going to start our server, and we're going to use an asynchronous or non-blocking function. So while our server is running, it can still listen to do other things. So this HTTP library that ships with Node, it has a create server method. Now we're going to write some code that's going to be a bit funky. He mentioned it in the video. We're going to write what's called a callback function. Now here's a little bit of a warning. Callback functions look very strange when we're used to using named functions. Okay, it's going to take a month or so before the callbacks stop looking so bizarre. And pretty soon, in a month or two, you'll be able to write them without even thinking about it. It's okay that it's going to look strange right now. It should look strange. So our create server takes one parameter, and that parameter is an anonymous function. It's anonymous. It has no name. And in here, this anonymous function takes two parameters, whoops, which is the HTTP request that comes in and the HTTP response we're going to generate and send back to the browser. So we have a function that's a parameter to another function, and that function has no name. So this is what's called, he mentioned in the video, a callback. And this structure is the whole key to Node's asynchronous model. We don't have to use an anonymous callback function, but if we don't, our code becomes blocking. This is what allows this function to run and then Node to carry on doing other things in the meantime. So we're going to send a response. So our response object lets us send headers. So we're going to send a 200 HTTP status code. Anybody have an idea what 200 means for HTTP status? Yeah, it means the request is okay. What other HTTP status codes have you ever seen before? There's one very popular one. What does 404 mean? Yeah, page is not found, not just a generic error, specific error. So this is where we can determine what kind of response code goes back to the browser. And now we can say response.write. So this is actually going to print to the browser. And then we need to end the response. If we don't end the response stream stays open and our page will hang forever. Nothing will ever actually get displayed. So that starts our server asynchronously. And then we need to also call the listen method inside our HTTP library where we specify a port. We can specify any port number. He used 8080 in the video. We're going to use 3000 because that's the default when we get into using the Express framework. So you can change that and run it on any port you want, but typically we're going to use 3000. And then let's display a message to the console as well. So not only are we going to be able to load this page in our browser and get this response, we also want that message to print out in our console or our terminal. So to try this out, we need to go back to our terminal, use the node command. Instead of running hello world, we need to run the server. If it works, it's going to print out this message in our command prompt. And then we should actually be able to go in our browser to localhost :3000 and get a 200 response that says our first node page. That's the goal. We'll try it. So I'll shrink this down a bit. I'll use my node command to launch the server. That's good. Our server's running on port 3000. And now let's try it. So if I go to localhost 3000, our response gets sent to the browser. And if I look actually in my so notice, here's our status code, HTTP status 200. So that's where that right headline, we're sending the status code back to the browser. If we sent 404, it would show up here. We can even see what method was used, which is get, which is the default HTTP method. There's no HTML on the page, just our base response. If we want to wrap this response in some HTML tags, let's say put an H1 opening and closing tag around, we can do that. So now in my response, in here, let's put in a little bit of HTML formatting. So I'll save that inside of my quotes. Now we'll refresh the page and see what happens. Yep. So notice when I refreshed, the page didn't change. There was no, my font didn't get any bigger. There was no bolding of that text. So what does that tell us about how our server and our code, what happens with our server when we make changes in our node code? Yeah, you have to restart the server. Okay. Now later on, we'll install a tool that will automatically do restarts whenever we save changes. Because stopping and starting the server every time, that's a big pain. So there's a tool that will monitor our node code for changes and do auto restarts. To stop the server, so notice that my command prompt is locked here. I can't actually type anything. The way to stop it is with Control-C. Now my server is offline. I'm back at my command prompt. If I go back to the browser and refresh, right, I've turned the server off. So I can either type node server, or in the command prompt, does anybody know how I can get it to repeat the last command? Yeah, if I press the up arrow, it'll show me, and I can keep scrolling through. It'll show me the last commands, so I don't have to retype them. So now I've made that change, saved my file, stopped and restarted my server, and now our code's been modified. Obviously, we've got our H1 tag taking effect. So the nice thing is we don't need to be uploading to any third-party server in this class. We can do all our classwork just running it on a local server. It's much faster. We don't have to use FTP. We don't have to transfer stuff. Later on, we'll need to use a cloud server for your assignments, but not yet. And there's several free cloud services that we have access to, and I'll show you how to create those accounts and how to get our code up there. Any questions so far? I'm just going to take out the response.end for a minute. I don't recommend you do this. I'm going to show you what happens if we send that response, but we never end it. So I'll just stop my server again, restart, and refresh. See, this is never, ever going to load. We're going to look at this forever because we've never ended our response, so our server's still waiting for that to end. So using that end function is critical after we send that response in. I better stop it because it's not going to stop on its own. So, and these two parameters, I didn't define them. They're built into Node. So the HTTP library always has a request that comes in and a response that goes out. So we'll use the request object for things like processing a form submission, right? In PHP, we use the post array that contained all the input fields. Well, in Node, we're going to use the request.body and then the name of each input field. That's how we can parse it. Or if we have parameters in our URL, again, we'll use request.params to get those values from the URL. Like, let's say we have an ID number on the end of a URL. We want to identify that ID number to do a database query. So we use request for that and response for anything we want to send back to the browser. Your page of work, you get it to run the browser? All right. So the last, I want to do two other quick files. I want to again follow along with one of the examples from the video. I want to create two simple text files, and we'll write two different Node files to read them. One that reads them asynchronously and one that reads them synchronously. So first of all, you can see the difference in how they run. And second of all, in the asynchronous version, we're going to get to write a couple more callback functions. Because again, we want to start to get familiar with this syntax, which I know is new for probably everybody or almost everybody. So let's make two text files. We just want to make two simple lists. So I'm just going to make a new, I'll just say new file, because text file isn't in my list. Let's make food.txt. All right, what'd you have for lunch today? That one? Okay, so we had cookies, we had sandwich. What else? Let's put about 8 or 10 things in here. What else have you eaten today?
Apple.
Air?
Yeah.
Okay. Anything else? What are you eating tonight for dinner?
Class.
I want 3 more things that somebody's eaten today. Sure. No, we'll put that in our next file. I had a salad.
Yogurt.
Yogurt. All right. Just put any 10 items in your list. Doesn't really matter. You can even just put A, B, C, D, whatever you like. So there's our food. And let's make a drinks text file as well. So I'll make a new file called drinks. What have you had to drink today? Coffee, water, iced tea. All right, that's a good list. We'll keep the list different sizes. So now we're going to make two different node files. First, let's do the blocking version. So one thing has to happen, then the next thing, then the next thing, then the next thing. Okay. So what we want to do, here's what we want to do in our file. We want to print a message that says displaying drinks. And then we want to print the drink list. Then we want to print a message that says displaying food and then display the food list. So we'll first do it a synchronous version, then we'll do an asynchronous version of the same thing. So let's make a new JavaScript file. Let's call it blocking.js. All this code will go up on GitHub after class. We're not using the HTTP library, but when we install Node, we also get a library called FS, which is used for manipulating files on the file system, reading files or writing files. If we want to do that, we need a reference to FS, so we'll just require it. If we don't use this library, we cannot read those text files from Node. So first, we'll deal with drinks. So first, let's print a message. Whoops. That says drinks. That's the first thing we want to do is print the heading. Now we want to read the drink file and then print out the contents as well. Each drink should be on a new line. So we'll use our file system object. It has a method, which called read file sync. So this code is synchronous or blocking. When this method is executing, nothing else can happen until it's done. Okay. So we want to read drinks.txt, and we have to specify the encoding type, just basic UTF-8 encoding. And now we'll print out the contents of the file to the command line. So we'll print a heading, we'll open the file, we'll read it, we'll print out the list of contents. We then want to do the exact same thing with our food. Print a heading, open the food file, print the list of foods. So we'll use the read file sync method again to open food.txt, and then we'll log out the food. I should point out that just like Java, JavaScript is case sensitive, and camel case is standard. So if you used a capital R there, that method's not going to work. Oops. So there's all our code. Should be fairly straightforward. So what we should see here is the word drinks, our list of 5 drinks, then our heading food, and our list of 10 food items. So if we want to launch this, all we need to do at our command prompt is run the command node space blocking, and it'll execute this file. Let's try it out. I'm not 100% sure we did it right. I think we did, but the only way to know is to try it and see. When I run blocking, here's what we get. Drinks, our list of drinks, food in our list of food?
How do you print a blank line?
Good question. So where would you like the blank line?
In between food and drinks.
So what we could do is simply \n for new line. So if I run it again, now we get a space after the list of drinks and before the word food. So we're basically doing 4 things here. Step 2 doesn't start till step 1 finishes. Step 3 doesn't finish till step 2 finishes. And step 4 doesn't start till step 3 finishes. So this is how a PHP page would run. This is how a Java application, a C# application, all the languages you've already learned and been working with, they're all going to run this way. And if we use a synchronous method, Node will run the same way. But Node isn't really designed. We're not usually going to use this version. So now let's write the same code, but this time we're going to use asynchronous functions with a callback. Our code will be non-blocking, and let's compare the results that we get. So if you want to go ahead and create one more JavaScript file, call it nonblocking.js. We're still going to need to require the FS library because we're using it to read the text files. So that first line of code is going to be the same. Now, in this case, let's actually read the drink file first, even before we print the heading. So instead of calling read file sync, which is blocking, we're going to just call read file. So the default methods are asynchronous. So let's read drinks.txt. But now we have a third parameter. So our first parameter is the file reading, second parameter is the encoding. The third parameter is going to be what? Yeah, our callback, our anonymous callback function. And when we write this anonymous callback function, so we're going to attempt to read the list of drinks. We're going to get one of 2 things back. We won't get both. What are the 2 possible responses we might get when we try and read that file? What 2 things could happen when our code tries to read a file? Yeah, we're either going to get an error or we're going to get the contents of the file back, one or the other, right? So in Node, when we run these callbacks, the first parameter is always an error. So if there's an error, this object will give us information about the error, so we can do error handling. If we don't get an error, what we will get back is some data, which we'll call drinks as just the variable name. So when our callback runs, print them out. But we've written this asynchronously, so this function doesn't stop the rest of our code from executing. Our rest of our page keeps loading, and it comes back here when it's finished. But now we'll print our heading. And what we should find, because our code is asynchronous, the heading should still be the first thing that prints. Why? Because this is going to take some time to do. But because our code is not blocking, it'll carry on and print this even before this finishes, is what we should find. So now let's do the same thing with the food. So we can basically repeat what's here. Let's read the food. So again, we're writing our anonymous callback function. So just a repeat of what we've done above, this time with the food. So now we can try this in our command line and see how it behaves. I'm just going to try it out. I'll put the code back up. So this time I'm going to run node and non-blocking. What do we get? So that's interesting. Notice what happened. Yeah, even before the drinks finished, not only did it print the drink heading, it also printed the food heading, right? Because both of these things happened. So this line executed and this line executed even before this finished. Right? So here we're only getting a few items, but if we're getting thousands of records, you can see how the asynchronous code is going to let our application run faster. Users are not waiting for things. Now, this isn't very good output, really. We have the food heading in the wrong place. How could we move the code around to make sure that the food heading doesn't print until after the list of drinks? So in this case, we don't actually want this line to be asynchronous, do we? The food heading shouldn't show up until after the drinks are finished. So we should move this somewhere else. We've got a couple of options. Where would you move it? So that this line doesn't show up until after that's finished. Okay, what line number would you move it to? You can see my line numbers here. Okay, well, there's two. This one, line 11 or line 15? Okay, so if we move this, right? Now these two functions are synchronous, right? Because they're inside of the same callback. So this will no longer happen until that finishes. So we'll try it again. There, that's better. So print the heading, get the contents, then wait until that's done before you start on the food. So we can control whether the code blocks or not. Here we're running mostly non-blocking, but we want this line, this code, to be blocking because we don't want it to start and run too early. Much like here, if we're going to send a confirmation of something that users save into the database, we're not going to want to send that email until we know we've saved their information correctly to the database. So we have that ability to make something block if we want to. We're not, we could. So that's a good point. So if we want to check the error, we would just do something like this. If we have an error, let's log it, and then we can either put in an else or we could just do a return. Right? Our code will stop if we get an error in this case. So let me break the name of the file. Rather than calling it drinks, I call it drink, right? So that file doesn't exist. we'll see if our error handler will kick in here. Right? So we got an error, so it prints out the error, but because we've handled it, our food still works. Right? If I don't have that little if statement, let me just comment it out for a minute. So if we don't do any error handling at all, well, it just gives us undefined. So it actually kept going, but we don't have any information about that error. So if we want to handle it, we can just use an if. We also have access to try catch, just like we do in Java. So typically that first parameter will be an error and we can trap for it. Did we get an error, yes or no? If so, let's do something with the error. So I realize this is new. Writing functions that have no names and that are passed as parameters to other functions, this is totally new. The whole idea of asynchronous code that doesn't necessarily execute in the order we write it in our file, that's totally new as well. That's fine. It is a very different way of thinking about things. And some of you may love it right away, and some of you may think, I'm not so comfortable with this. I'm not sure I like this. That's fine too. But it will become more familiar the more we do this. Does anybody have any questions about, I mean, that's all the Node code I wanted to write today.
Do we need to assign these two variables, like war drinks? We could just start with fs.readFile.
Let's see. In this case, we don't need to assign it to a variable because the read file is filling the data here and we're using that value inside of the function. So yes, it should still run the same even without that. Good question. If we wanted to use that data outside of this function though, then we would need to assign it to a variable.
But how, like, the data would pass in the drinks too?
Yes, it would. So because we're setting it equal, we could use that even down here. It's now global in our file, so we could use it in other parts of the file as well. So this one is local, but this one is global within the file. Good, very good question.
But we can use this variable as, like, instead of putting the food in drinks, we can call in other functions when this is complete.
Yes, we could. We could do it that way.
It was in the video that we showed.
Yeah.
Is it possible to name your errors so that they're more user-friendly? Well, you can in what, Bash?
I think in that case, you'd probably want to throw an error. So you would do a try, you'd throw a particular type of error, and then yes, you could name it. But by default, Node names that first parameter as error. That's a Node default. It expects that first parameter. If there is an error, it will fill that first parameter. So both of these parameters won't get filled, one or the other, but not both. And error is typically the first one. Okay, so here's what we want to do. What I want to do, since we're done coding for today, I want to put all of my code up on GitHub. So then A, you have access to it, and B, I want you to put all your code up on GitHub so we can learn how to use it. And then I'm going to give you your lab. Has anybody used GitHub before? What's the whole point of it? Why do we use it? It kind of has a few purposes. Okay, yep, so that's the primary reason. What do we mean by version control? Okay, yep, so we can work together. We can share code and merge our code. Yep, so it's an open source repository. We can track what's being changed. Yeah, we can collaborate. And why is the version control piece so important? Even if you're not collaborating, let's say you're doing a project all on your own. Why do we need version control, Nick? Right, because something you add today may break something you did a long time ago. And this happens way more than you think. Because you know why? If you write a successful application, that application is hopefully going to be used for many years. I'm updating a website right now that I built in 2006. It's pretty easy for me to break something that I wrote 10 years ago. I don't remember how things are supposed to work. So if I break something by archiving my code on GitHub, I can always go back and get an older version. I haven't lost or overwritten my code, right? Plus, it's also offline cloud storage backup. You lose your machine, it gets stolen, it breaks, all your code repositories are online. So I asked you all, does everybody have a GitHub account? If you don't have one, please go to github.com right now and create a free account. If you do have a free account, if you do have one, I'm not sure if you have access to private repositories yet or not. Right. So if you have a GitHub account already, you can use another source control. If you're not using GitHub, you're gonna have to use an alternative like Bitbucket or something else. But it is a requirement for the course. The reason why I suggest GitHub, Joel, is GitHub is integrated with most cloud hosts. So the idea is rather than FTPing our node files to a server, we don't use FTP anymore in this class. You deploy it to GitHub, and your GitHub repository connects directly to your cloud server. And every time you upload a change to GitHub, that change automatically gets deployed to the cloud. And most of the alternatives to GitHub don't offer that. So if you don't already have your GitHub student pack, I want you to go to education.github.com and click Get the Pack. Make sure you're logged into your GitHub account while you're doing this. It gives you all kinds of free stuff, like a bunch of cloud hosting credits on places like Amazon or DigitalOcean. Gives you some other cool things too. It gives you access to private repositories. So your lesson files each week, you can make those public, right? We're all gonna have the same files, who cares? But for your assignments, your repositories need to be private and use it. Okay. Normally GitHub charges for private repositories, but they don't charge students. So if you have a student account, you can create a private repository and they won't ask you for your credit card. They also have, through Namecheap, they give you an SSL certificate, free for a year, and they give you your own domain name, free for a year. It's cool. And you get some other things along with this. So if you already have a GitHub account, when you click Get the Pack, it asks you for your student email, and they'll send you an email where you just click the link and verify. And then what you need to do is you need to add your student email to your GitHub account. It's really simple. Here's how you do it. You go to your account settings, so click your little avatar, click on your profile. Sorry, it's under settings, my mistake. So click settings, and under emails, just add your student email address. In the add email box, just type your student email and click add. So if you verified your email as a student email and you've added it to your account, it will now let you create private repositories and it won't charge you. And I don't want you guys, everything we do in this course is free. You don't have to pay for anything other than your seat in the room. You've already done that. So once you're set up, we want to push our code from today up to GitHub. And then I'm going to give you your lab, which is just doing creating a second repository and making some changes to your code on GitHub. You're already done. So each week, I'm going to make a new repository with the files from that week's class, and I will publish them to GitHub right at the end of class. So what I'm going to do is I want to create a repository for today. So when you're signed into GitHub, if you don't have the student account yet, you don't have to worry about it yet. You can always do it after class. Doesn't matter if today's repository is public. No big deal. So if I click on create new repository, I'm going to give it a name. So I'll call it COMP2068, Lesson 1, Winter 2017. I'll put in a description. So when you're looking at the repositories, if you miss a class, you know what we did in each week. Okay. So first, node samples, hello world, HTTP, versus. This is optional. You don't have to put this in. And if you've created a student account, if you want, you can choose private. If your student account isn't set up yet, when you choose private, it asks you to pay. Please don't pay. You can just make it public. The git ignore allows you to say, don't upload certain file types. If they're library files and they're just going to take up space, you can ignore certain file extensions. I'm going to leave this box unchecked for now. Does anybody know what the README file is for? Most GitHub repositories have a README. What do we do with that README usually?
Information on the project or documentation.
Yeah, that's usually the documentation. So if we open source something, we find an open source project on GitHub, the README is going to tell you how to use it. So we don't need a README file. I'll maybe put READMEs on mine that again describe what we're doing in the lesson. You don't really need them for now. For your assignments, I'd like you to create a README file that explains what you're doing. So I'll just click create repository. And it gives us all the commands we need to run in the command line so we have an empty repository now, an empty project on GitHub. We want to upload our code we did today, the text files and the 4 node files, into this repository. So if we lose our computers, our code is here. We want to go into a job interview and tell someone, hey, you want to check out my node code? Not only you can see the application, you actually look under the hood and look at my code. Here's the repository link. Here's my Git page. So I'm going to go back to my command prompt. I'll just shrink it down a bit. And I'll clear out my command prompt with CLS. I'll get rid of all the commands we've run so far. So the first thing we need to do is we need to initialize Git in this local folder. So Git will track the changes in our folder anytime we make new files, delete files, or change them. So the first command is git init. Initialize Git in our lesson 1 folder. And hit enter. So it's initialized an empty Git repository. So we now have an empty repository on GitHub. We have an empty repository locally. The next thing we want to do, we won't follow this exactly, is we want to add all of the files we did today into the repository. So if we type git space add space dot. The dot is a wildcard. I don't know why it's not a star. If I was writing the language, it would be git add star, but it's git add dot. Typically, but Git's actually a Linux-based tool. So that will copy all of the files. Git's now watching those files. So if we make changes, Git will know we've changed them and we can make a new version. Now we need to do this command, git commit. So a commit, that's like a snapshot. It's creating a new version. So now we're not going to do a new commit every time we save a change. That's too crazy. So how often, if we're working on a project, how often do you think it would make sense to make new commits? There's no rule about this, but there's a few guidelines. When would you make a new commit? If you're working on a project, let's say it takes you a month. Okay, so anytime you've made a major change, you may want to make a new commit, a new version. When you solve an issue. Yep, could be. Yeah, it could be when you're done. I typically do it when I'm done working for the day. As I'm working on something, I don't commit it to Git. But once I'm done for the day, yeah, I'm going to do that. I'm going to make sure if I lose my machine that I have the current copy. It also means that if I'm working with someone else, when I'm done for the day, I want to commit and upload my changes to GitHub so my coworkers can download and sync those changes. So we're going to do git space commit -m. The -m stands for message. And then in double quotes, we want to put in some message that describes what we did in this version. I have students now on all your assignments, you get on your big projects, you get marks for using Git and doing regular commits. If you name the commits, commit 1, commit 2, commit 3, you won't get full marks. What's the problem with naming them commit 1, commit 2, commit 3? Why is that not a good idea? Could be overlap, yeah.
We can't know what the purpose of commit.
Right. If in a month you break something, if you've named them commit 1, commit 2, commit 3, there's no description of each version, so you don't know which version to go back to. So your commit messages should be descriptive. So I'll call this end of class files. That describes what's in this version. So it adds our text files and our 4 JavaScript files. Now this code is not on GitHub yet. It's still only on my machine. If I lose my machine, my code hasn't been backed up. It only means if I break it on this machine tomorrow, I can pull out today's version now. So now we want to connect our local repository to the online GitHub repository. And we do this. So this is kind of like connecting to a server with FTP using FileZilla, which you probably did in Sean's class. We only need to do this once. We don't need to do it again. I'm just going to copy that whole line. And the command is remote add origin, and then the URL to my new repository. So I'll just highlight that line. You can type it if you want. Why type it when we can copy it? They're already here. Here's my main GitHub page, and all the repositories are there. They'll always be here. Okay?
And the instructions? Along with the instructions?
Well, the instructions, GitHub gives you the instructions every time you hit new repository. It actually prints them. Okay. Plus, I'm recording this to YouTube, so you can also always go back and watch video anytime. In a few weeks, you'll be able to do this like that. So now at my command prompt, you can't use Control-V, but you can right-click and paste. So paste in that command and hit enter. So now my local repository is linked to my online repository. But our code hasn't been uploaded yet. To upload, we need to run this last command. Git push -u, which means unconditional, from the origin to the master branch. We talked about different branches or different versions. So I can then just copy this line, or I can type it. Copy and paste, and hit enter. And now if I refresh, actually I'll leave this open. I'll just copy it and put it in a new tab so you can still see the commands. Now if I load my repository, the instructions go away, and it says I've got 1 commit, and here's where we see the commit messages. And I've got a description of my repository. Now, if I lose my laptop, all my files are online. I can just go and I can download the repository as a zip file. If I want to share it with, if Tiffany's going to work on this with me, she can just go join the repository, grab a copy, and then we can merge our versions later.
How do you view the instructions again? And mine never popped up in the first place.
I'll just leave it right here. Whenever you create a new repository, it shows you this. This is only one method of getting it on GitHub. There's lots of other ones. You can do it right through WebStorm or Visual Studio Code. It has a version control right here. So if you want, you can upload right from here. I also asked you, there's also a desktop tool where you don't have to type any commands. So you may prefer this. It looks like this. So if I want to make changes, I'm now going to show you what happens when we make changes, how we add those changes. So here's my GitHub desktop tool, which I asked you to install. If you prefer to use this rather than the command line, that's fine. It does the same things. So if I click on my plus sign here and click on add, it asks me to browse. So I'm going to open my lesson 1 repository now through the desktop client. So it shows me my files. So I'm going to go back to my code and I'm going to change something. I'm going to open up my drinks. I'm going to add it, make a change in this file. I've added one new thing to my code and I've hit save. If I go back to my desktop client, notice I've got a little blue dot here. It says you've got new changes. So Git is watching this folder for any changes, new files, files removed, or content changes in files. I click changes and it tells me, hey, you changed drinks. If I click on it, it actually shows me what change was made, which is really helpful when I'm working with someone else. So now I want to push this new change up to GitHub. So I'm going to make a second commit and I'm going to put in a description. So added beer to drink list. And we can't quite, oops. So now I'll hit commit. So I've made a second commit. And now it's saying you've committed locally. If I go back to my browser though, and refresh, notice it's still only showing one commit. And when I click the drinks file, there's no beer in here yet. So what do I need to do to publish my changes to GitHub? Yeah, if I click sync, the reason it doesn't just say push is it will first pull any changes. So if you and I are working together, maybe you've put changes on the repository. I want to download your changes first. So I have your changes before you get mine. So when I sync, it'll check online for changes. And now it shows 2 commits. So these small circles, those are synced commits. So what I have locally matches what's online. If I go back to my browser now and refresh, now I have 2 commits. I can see the 2 different commit messages. And now drinks is uploaded.
Did you do the commit through the desktop GitHub?
Yeah, I did the first one through the command line and I did the second one through the desktop. So to do it through the desktop, notice changes, it's now blue and there's no circle here. When I made the change, it shows me a little blue circle up here.
Yeah.
So I put in a message here and then I click the commit to master button. So this way I can click on the commits and I can see all of my previous versions and what was changed in each one. And I can go back to any version. So part of what you have to do for assignment 1 and assignment 2, there are marks simply for making regular commits to GitHub. And that way also I can see all your code online. You don't have to zip it and upload it to Blackboard, and I don't have to download it from there. I can actually just look at your code online on GitHub, which means I can get you your marks faster. Saves time. So what does this look like if I go back to my main GitHub page, show you a student project from last semester, it would look something like this. Oops. Let's see. Okay, so here was someone's final assignment from last semester where he built out, can't remember what he built, didn't mention. So he did 28 commits over 3 weeks working on assignment 2. And each time he made notes about what things he was working on and what he was changing, right? All his code is here, and he could be working with someone else and they could share this repository and share changes this way. So I've made 2 commits now. The first one I committed from the command line. Second one I committed from the desktop client. I'm going to do one other thing. Go back to my repository. So I'm going to create a README file, and I'm going to do that online. So now I'm going to make a change. I'm going to do the change on GitHub, but then I need to pull or download that change to my local version, because now GitHub's going to have a file that I don't have on my laptop. So here it says, help people interested in your repository understand your project by adding a README. So let's do that. I'll click add a README. It has an MD extension, stands for Markdown. So we can write HTML tags, or we can do it just with regular formatting. So maybe here I'll add an H1. So I'll put these as a HTML list instead. And I'll put a link to the YouTube video here, why not? You can put whatever you like in here. You don't have to follow my... You can put any text in. Here's what it'll look like. So it's a description of what we did in this repository. And we need to make a new commit when we want to save that file. So I'll say create README. So I'll make a new commit. So now I have 3 commits. And when users first come to the repository, they see my documentation, they see my README file. But notice I have the README file online, but now my 2 versions are out of sync. Online has this file, but I don't have that file here. There is no README. So how could I very simply download my README file from the GitHub website to my local folder? Yeah, I could either do a git pull at the command line, or I can just click the sync button in my little desktop client. Pull changes. So now I'm going to download that README, or as well as any other changes that were made online. So now I've got 3 versions. And now if I go back to my, now the README file has been downloaded when I did sync. If I look at WebStorm, the README file's now been copied. So I'm just going to give you your lab, let you out here in 30 seconds. So here's your lab, due Friday night. It's under assignments. Here's what you need to do. So create a new repository called Lab1. upload a copy of this text file into your repository. So make a commit. You can put in a message, you know, uploading the assignment text file. Hang on, we'll be done in a minute.
Okay.
So that'll be your first commit. Once you've uploaded it, open up the document in your browser on GitHub, change something, just add a line of text. Say, you know, editing this file from GitHub. Save it, and that'll make a second commit. Then you'll hit sync or pull to download it back to your computer, make one more change on your computer and upload it and push it back to GitHub. So I'll see 3 commits on GitHub. So the first version will have this document exactly. The second version will have a change you made online. The third version will have a change you made back on your computer as well. All you need to do for 2.5% is submit the link to your lab on Blackboard. That's it. All I'm going to do is click on the link, see that you've set up a repository, and I'll see the 3 commits, and I'll check that each time the file was changed. Okay? This should take you about as long as it just took us. So you can use the command line, you can use your code editor, you can use the desktop tool, you can use any one of those things. Okay? So you have until Friday at midnight. It's 2.5% of your mark. This should take you 5 minutes to do. Okay? And again, if you want to watch the video or see my GitHub page, weekly learning tools and resources, those are the first 2 items. The video as well as my own GitHub. Okay, that's it for this week. Have a good week. So next week, we're going to do some basic JavaScript practice, and we'll do a little JavaScript lab at the end of class.
Could you go back to your command line, please?
Sure. Do you want me to go up?
Yes, please. It's the last Git line.
Okay.
Yeah, there. Git remote added.
Yep. So those 2 commands were just copied and pasted.
I even tried making another repository and the instructions didn't show up.
Okay, I'll come have a look quickly. I'm just going to stop my video stream.